Hi everyone, thanks for tuning into our second video on applications of systems of equations. This actually was a mastery problem, mastery part 2 that we did in class. I actually just wanted to make a follow-up video here so that if you weren't in class when we went over this, you could check to see how well you did. So I'm just going to kind of treat this as if it were notes, but really you should already have this done and just simply be checking along with me to see how you did. So I'm just going to remind you, I'm going to go ahead and read the problem so we're all on the same page here. It says, John needs to buy cleaning supplies for camp. So he decides to buy towels and soap. John buys 20 packages of cleaning supplies altogether. Towels cost $6 per package. Soap costs $4 per package. And he spends a total of $94. How many packages of towels and soap did John buy? And so you know from our prior video and work in class that one of the first things I always want you to do when you're solving a system of equations as an application is to define your variables. And to do that, your variables are what you're trying to find. You're going to choose a letter to hold the place of what you're trying to find until you find it. Okay, so if you look at this last sentence, which is typically where you find the question, it says, how many packages of towels and soap did John buy? That's what we're looking for. How many packages of towels did he buy? How many packages of soap did he buy? So that's two things. So we need two letters. So I'm thinking T for packages of towels and S for packages of soap. Now, the only thing about this that I can foresee is that, and I'll write this up here, a T can look like a plus sign. So T is actually a variable I kind of like to stay away from if possible, unless you're going to really exaggerate it and make it like a cursive T. But even then, I don't like how much it resembles a plus sign. So I'm going to go back to good old faithful on this one and use X and Y. So I am going to let X equal the number of packages of towels John buys. And notice how specific I am here. I don't want you just putting, hey, X is towels. Well, what about the towels? The color, the size, the fabric? You want to be specific here. You want your reader to know that you know exactly what you're looking for with these towels. You're looking for how many packages did he buy. Likewise, we'll let Y equal the number of packages of soap John buys. So check what you had. If you chose different letters, that's okay. Our answers will come out the same. All right, let's look at letter B. Write the system of equations that represents the situation described. Okay. Now, being that this is Algebra 1, our system of equations is most likely going to have just two equations, and there's money involved. And whenever there's money involved, it is typical to have both a quantity equation that has nothing to do with money, and then to have all the money in a different equation. So let's look at quantity first. All right, so basically just like, how many packages of towels and soap did John buy? And if you scour the problem, you can find it pretty early on in this 20 right here. John buys 20 packages of supplies. That has nothing to do with money. Quantity. So the number of packages of towels added to the number of packages of soap makes a total of 20 total packages. Now we get into the cost. So what does a package of towels cost? Well, scour the problem. Towels cost $6. So it's going to cost us $6 for every package of towels. And we're going to add that to the cost of the soap. $4 for soap. $4 for every package of soap, and that makes a total of $94. And there's your system of equations. So check your work. Hopefully you have that system written. And now part C says that we are to solve it. And I'm guessing you went by elimination. Now for me, what I'm going to do is I'm going to recopy these. X plus y equals 20 alongside 6x plus 4y equals 94. And I want to do elimination, so I am going to multiply my top equation by -6, because then my -6x and my positive 6x will eliminate. So if I push my arrows to the right, let's write our new top equation. So with a little distributive action here, we're going to get -6x minus 6y equals -120. On the bottom, we keep it exactly as is. 6x plus 4y is equal to 94, and we're going to add these together. Okay. -6x plus 6x eliminates. -6y plus 4y is a -2y. And -120 plus 94, let's see, is that, if you have your calculator, -120 plus 94, 94, -26. We'll divide both sides by -2, and so y makes positive 13. So let's just go ahead and figure out what that means. Let's remember what y was. Y was the number of packages of soap that John bought. So when I go down to letter E, how many packages of soap did John buy? I'm going to say John bought 13 packages of soap. Okay. Now to find the packages of towels he bought, we simply take our 13 for y and substitute it back into one of our equations. I'm thinking the top equation's easiest. It has less going on, so I'll say x plus 13 equals 20. Subtract 13 from both sides, and we get x equals 7. So 7 packages of towels. So John bought 7 packages of towels. So how did you do? Okay, did you check your work? I mean, here's a good question. Did you check it? So let's go back up here. Does 7 plus 13 make 20? And I would say yes, it does. And how about the money? Does the money work out? Does $6 a package times 7 packages of towels plus $4 per package times 13 packages of soap, does that make $94? Well, let's see. 6 times 7 is $42 plus 4 times 13 is $52. Does that make 94? Sure does, 94. So I'm feeling pretty darn confident about my answers here. And you see all this work. This is a great practice problem for like a keystone constructed response question where you have to construct and demonstrate all the work to prove that you can solve a system of equations. So thanks for tuning in, and I'll see you next video.